Okay, let's get back to the half interval search for solving f of x equals 0 in Python and Perl. And let's take a look at the source code. So the upper screen, the upper window rather, is the Python. We're going to import math, define the average function, define the error tolerance to be 0.001, then define the auxiliary function is small enough, declare that error tolerance is a global reference, and then return true if the absolute difference between x and y is less than or equal to error tolerance. Here's Python in my Emacs window. We're going to define the error tolerance scalar variable. Then this is the subroutine for average, the average of the first and second argument. Then is small enough that returns 1 if the absolute difference between the first and second argument is less than or equal to the error tolerance. And this is the workhorse interval search in Python. It takes the function object, the negative point and the positive point of the interval that we're searching, computes the midpoint of the interval, because interval search works similar on the same principle as the binary search. If the interval is small enough, the difference between negative point and the positive point, then simply return the midpoint, because it's as good as it gets, as our approximation allows to get. Otherwise, we compute the value of f at midpoint. If that value is less than 0, then we're going to half the interval and reduce it to the interval from the midpoint to the positive point. If the f of midpoint is greater than 0, then the interval is halved, and we're going to search from the negative point to the midpoint, because midpoint is positive. Otherwise, f of midpoint is 0, and we simply return that midpoint. We found the solution. Now let's go to Perl. Same logic, so unpack the argument array into the reference to a function, the scalar negative point and the scalar positive point. Well, subref is also a scalar, but it's a reference to function. This is how we compute the average, right, of the negative point and midpoint. If it is small enough, then we simply return the scalar midpoint. Otherwise, we call the function reference on the midpoint, right, and obtain the value of the function at that midpoint. If that value is greater than 0, less than 0 rather, then the interval becomes from the midpoint to the positive point. If it is greater than 0, then we search from the negative point to the midpoint. Otherwise, we simply return the midpoint, because it must be 0, f of the value of that function at midpoint. This is the top level call. Let's go half interval search that essentially takes the function and then value of a and b, the interval values. Decide which is the negative point, which is the positive point, by evaluating f of a and f of b. So if a of v is less than 0 and b of v is greater than 0, then a is the negative point and b is the positive point. And we do the same in Perl, right? So the subref is called on a and on b, and if a of v is less than 0 and b of v is greater than 0, then a is the negative point and b is the positive point. Similarly, back to Python, so if a of v is greater than 0 and b of v is less than 0, then b is the negative point and a is the positive point. So, and then Perl, that same logic is here. So the only thing is different, that's else if without with an s added, right? Okay, if otherwise we raise the error, values must be of opposite sign, and we die in Perl. So because the integral bounds must be of positive sign. So let's define a few polynomial functions, x cubed minus 2x minus 3, then x to the fifth, 5x minus 5x minus 5, minus x plus 2, and the same polynomial subroutines in Perl. We're going to look for the zeros of these polynomials and cosine. Here we wrap the cosine, call the cosine inside the subroutine, wrap cosine. So, and this is how we call the half interval search. Returns the zero of the function, and we print it all out and evaluate the polynomial at that 0 point. So let's notice the reference in Perl /n. This is how we obtain the subroutine reference. So same with poly 03, right, on the interval from 1 to 2. And then we're going to search poly the third polynomial on the interval from 0 to 10. I'm just noticing that I'm calling, calling the third polynomial on the interval from 1 to 10 instead of 0 to 10. Well, okay, I'll correct my comments on the calls in the GitHub source code. The zeros are still going to be the same. Okay, so this is the idle evaluation on of those half interval search calls. So this is the 0 point of the first polynomial, and this is the evaluation of poly 01 on that polynomial, and the same with the second polynomial, 0 of the second polynomial. They're very close to 0 actually, the values of the polynomials on those functions. This is the value of the cosine at the found polynomial on the given interval from 9 to 12. So let's go to command line. I'm doing it on Windows, and we can look at these values. They're actually very close to what Python gives us. So almost 0, very small value. So this is the Python value. This is the value of the first polynomial on the 0.01. This is the value of the second polynomial in Python on the 0 point, right? So this is the third 0 point, very close. This is the value of the third polynomial on that point. And finally we have the cosine, right, the fourth line. Okay, well they seem to be pretty close to each other in both languages.